I am going to talk now about my project, the Weather Instruments and Problem Solving with Computer-Aided Design. I am the school librarian, so I only see my students twice a week on most years, but this year, since we were virtual for the first part of the year, then on a hybrid schedule where they were only on for 2 days a week all the way through February, I only saw them once a week. So my project didn't go as deep as I hoped it would when I first proposed it in some ways, but in other ways it went out even farther than expected. I'm sorry, I'm getting an echo. Is that Jennifer maybe? Okay. I just want to make sure I wasn't echoing to everybody. Thank you, Jennifer. Okay, so our project was to develop weather instruments using computer-aided design program called Tinkercad and our MakerBot sketch to print those out. We definitely saw interest in our CAD and STEM solutions in our school. I also did like pre and post surveys of students, and I was really pleased to see kids who thought that they wouldn't be able to do it, reporting how much success they had and how interested they were at the end. They did learn to design simple weather instruments in 6th grade, which was my original proposal, dog hassles in 4th grade, which was our 4th grade, which was included in my original proposal for them to work with our humanitarian project that we do with the a dog and pet rescue program. So they did some designs in CAD for that. And then the project that I didn't include in my original proposal that we did this year was with 5th grade, doing some signs for our school library and also some individual projects that they are incorporating with the little bits that I got from SteadTrain several years ago. As I said before, we did have a lot of challenges with remote and hybrid learning. It didn't allow us as much time as we wanted to have, but I solved that problem by expanding to more grade levels so that we could still use it more robustly. And that also opened up the idea of having stronger mentorships and getting kids started earlier so that they could be good mentors by the time they're in 6th grade. It was hard for my kids to be good mentors as I planned for them this year because they didn't have as much time with the project in the first semester as I expected them to have. But they did complete one entire engineering design process by creating a rain gauge, and then they went on to problem solve a second weather instrument on their own. 2 teachers at our school completed the MakerBot operator and design thinking certification, and 5 students are completing that certification right now. Okay, so next slide. These are some of the photos from our project. I don't see my dog houses on there. I don't know what I did. I must not have put that on there correctly. But you can see they had some really creative ideas for the rain gauges. We talked about how to get accurate measurements and which one was most likely to give us those accurate measurements based on the designs. The bottom left picture is one from the 5th grade group that was not originally part of my proposal, but you can see they're taking their CAD experience to the next level, I feel like. These girls, this is 2 girls that have designed a box fan to sit on their desk. That little motor mount that's sticking out of the back of the fan is going to attach to one of the little bits that we have that will power their fan to actually operate and cool them. And they were thinking in terms of air circulation and keeping the rooms more germ-free. That's their solution there. I do have some weather vanes that kids have been designing in Tinkercad. That's on the right, and then those signs for the library up at the top right for our categories in our library. Okay, next slide. This was our attempt to get accurate measurements on our rainwater collections because when we decided to design rain gauges with the Tinkercad and MakerBot, it wasn't clear that we would not be able to get transparent filament. We thought we were going to be able to see through the filament with this translucent filament that we got. But we couldn't see all the way through without shining a light on it. We talked about several different solutions. Some kids suggested, how about we put some food coloring in there, then we can see the line as the water goes up, or we'll just put a ruler in or something else afterwards. But we have these little micro bits that we got with another grant. So instead, what we decided to do was we have designed a little pitch accelerometer tool there with the cardboard on a pendulum. And as the water is poured into the rain gauge or comes into the rain gauge through rainfall, it lifts a ball that's inside there, kind of like a float in your gas tank. And that is connecting with a radio signal to another microbit that is charting the data on the plot that you see on the big screen. And so we talked about how to transfer that information, which is a pitch measurement, and the percentage change that we see on that recording, to how much capacity the rain gauge has, and then they can figure out how many inches of rainfall has fallen. So they got to do a lot of problem solving around the fact that our rain gauges were not perfectly clear, and I think that they really enjoyed thinking through that problem in a very real way and not just giving up and saying, oh, well, we'll have to design something else. They kept researching and figuring out how to solve that problem. Okay, next slide. So the students did complete one cycle of the engineering design process. They peer reviewed each other's rain gauges and gave solutions to how to solve that big problem we all had together about being able to see through it. They learned to collect and analyze that real world weather data using the tools that they designed. They are working on an anemometer that's also hooked up to another microbit, so we're still working out those problems. As I said, 5 students are in the process of completing their MakerBot certification, and 6 of them have mentored younger students on their projects and are making videos to welcome and introduce our next year students to this project. And so that was my experience this year. I really want to thank you again for funding it. I think it's going to be a big success in our school for many years to come, that we might not do weather instruments every year, but we'll always be doing something with the engineering process and computer-aided design.